Hi, I'm Katrina Ingram. Welcome to Back to School Again, the show for midlife learners. For this special mini-season, I'm thrilled to partner with Athabasca University to bring you a 3-part series focused on the future of learning and the power of online learning. This year marks Athabasca U's 50th anniversary, and they're celebrating with a series of exciting events and initiatives that explore the future of learning in the next 50 years. I've recently completed Athabasca U's PowerEd course on AI called Using Machine Learning for Competitive Advantage. This was a great fit for me because, as listeners know, I'm working on my master's and I'll be conducting my final research project on artificial intelligence and ethics. Speaking of ethics, I should disclose that Athabasca U allowed me to take this course for free. I recently had the chance to sit down with one of the subject matter experts from the course, Marcin Mizianty. Here's our conversation. My guest today is Marcin Mizianty. Marcin is the VP Data Science for AltaML. He holds a PhD in Software Engineering and Intelligent Systems from the University of Alberta. Prior to joining AltaML, Marcin has held senior roles as a data scientist at local technology firms. He also teaches data science and machine learning with Athabasca University's PowerEd course, Machine Learning for Competitive Advantage, which I've recently completed. Welcome, Marcin.
Hello, Katrina. Thank you for having me here.
Thanks for being here. So, Marcin, before we jump into talking about machine learning, I'd love to know, how did you get interested in the topics of data science, machine learning, and AI, and what made you decide to complete a PhD in this area?
Yes, so that was a bit of accidental, maybe not as planned. I should probably tell I discovered this great potential that this field will be booming in 10 years, and then that's why I decided to that. But it was more, I was looking to do some PhD, some research, and met my future supervisor through some connections, and he told me about this field. And I decided it sounds interesting and let's do a test. He was my supervisor for my master thesis as well. And then I discovered that this is actually pretty amazing field that enables machines to learn from the data. You don't have to write the algorithms, actual rules to do something, some actions, but you can just feed the data in and teach a system to respond to the data.
Very interesting. So you'd love to say you predicted how hot this would be right now, but it sounds like it was a little accidental or serendipitous. And this is a hot topic right now. I mean, everybody's talking about machine learning, but for those of us without PhDs in computer science, it can feel a little intimidating. And there's so much new terminology to learn. And that's something I really appreciated in taking this course because it looks at machine learning from a non-technical perspective, and you don't need any prior knowledge of machine learning to get started. So it's really for the average business person who wants to better understand how machine learning could be applied to their business. So let's maybe start with some of the basics. Marcin, when you're talking to non-technical people, how do you explain machine learning to them?
That's actually a hard thing to do because a lot of people have this misconception that comes mostly from Hollywood movies. HAL, Terminator, all this concept that this artificial intelligence can do everything. We are not at this stage. It's more down to earth, specific tasks. I typically explain it by providing an example. Let's say we have some data set about patients or tests on people where we take blood and measuring different parameters of blood, like glucose level or the levels of vitamins. Then we can assign people with the labels, healthy or sick, and reason about it. Like if there's a high glucose level but low level of something else, that is indication of some disease. So we could just provide the data and the labels, and the machine learning algorithm would learn the patterns. So then you can actually send the new data that will make predictions whether that patient is healthy or sick.
That's a really great example. And I think it really helps us to understand what's possible because you're right. We do get a lot of our information from Hollywood. And in fact, Corey Jansen, who's the CEO of AltaML and who's also one of the instructors in this course, he raised that point that we think of Terminator, we think of Skynet, and we think that artificial general intelligence is just around the corner. And the reality is that we're not really there yet. However, that doesn't mean that artificial artificial narrow intelligence isn't something that can be useful. And in fact, it's all around us, from spam filters to airplane autopilot to measuring glucose levels. I'm wondering about your role at AltaML and what kinds of business problems you are helping organizations solve.
A lot of different business problems. So one of our mandate when we start in collaboration with a company is to learn about their problems. What can they optimize? What can they reduce? What can be automated? We're looking for problems where some level of intelligent decision making is needed for some kind of recognition or characterization, something that cannot be automated using traditional software development because of that complex intelligent decision, but not complex to the degree where you setting up the new strategy for the company and reason about the different inputs. It's more like, based on this data, is it good or bad, or is it like healthy or sick patient, right? So you can streamline the process and automate the decision making.
Great. Are there any projects that you're really excited about that you're either working on right now or you've worked on recently that you can share with us?
Yes, there's a lot of ones that I'm excited about, but I cannot share, unfortunately.
Top secret.
But there are a few that are very excited and they're more public. One of the very interesting area is, of course, in health. The concept that we can help preventing diseases or streamlining the healthcare system to make it more general and accepting more patients, well, hopefully less patients, but being able to help more people. One of the projects is where we partner with Dynalife to use computer vision to help them reduce the time they spending on analyzing samples and the costs. So the test should be cheaper, but also the results would be available faster. Another project from totally different field is for Williams Engineering. They need to bid for proposals, and we develop a system where we predicting the probability of them winning the bid. So that can streamline their process where they deciding whether they should invest into formulating the proposal or they should actually drop it and focus on something else. With high probability, they should spend time. With low probability, they can save their costs and probably do something else.
Those are really interesting examples. And I think in particular, healthcare and testing is something that's on our mind these days, just given where world events that are happening around us. But also the example of Williams Engineering shows the range of where you can apply machine learning. And I think that's really fascinating. We're going to talk a bit more about the steps of a machine learning project. So in this course, we learned about 5 basic steps of a machine learning project, and those are defining the business problem, extracting and interpreting data, designing the project, building and testing the model, also known as the question answering machine. They called it that in the course, and then deploying the solution. And one of the key steps, perhaps the most important step, is the first one, defining the business problem. So I'm wondering if you can talk a bit more about why this is such an important step and what's really involved in this stage. Who should take part in this work? How long does it take? What does that step look like, defining the business problem?
I keep stressing it everywhere. That is the hardest part of the data science, to properly define what we're trying to solve. What universities are mostly teaching, especially on undergrad level and maybe more on the master level, it's how to solve a problem, but not always how to define a problem. In industry, a lot of people know what their problem is. Oh, we want to automate that, or we want to optimize that. But then actually characterizing it and writing it down, defining it for the use of machine learning, that's not as straightforward. There has to be a lot of thought put into the process. What are the potential biases? What are the potential drawbacks of this application? Does it really answer the initial business use case? So there are 2 steps, I think, to this process. One is to ask the question to our partners who want the machine learning system or the business, what is your problem? And then the second step is to translate that problem to machine learning experiment, to define what are we predicting, what kind of data is available, where we can take that data. Is that data having enough information for us to build that model or not? So who should be involved in that process? Someone definitely from the business side. I will call it client, but it could be also internal, like some stakeholder from the business unit who is interested in solving that problem. And also some product manager maybe, or business analyst who also understand machine learning better. And I would say it would be good to involve some senior technical people who saw many use cases and know what's possible, because they also may have some other approaches to the problem beyond the standard approaches that may be better fitted to solve that particular problem. Maybe they did similar use case in past and they know what questions to ask or how to formalize the data exploration process.
It sounds like it's a real team effort in nailing this step and getting it right. And it's such an important piece of the work because it just defines everything after it. One of the things that I really appreciated about this course is the way it took abstract theory and married it with real world examples. And the scenarios in the course were really helpful. And there were 2 questions that were used in the course to help assess, is this a good project for machine learning? And they were, are there any repetitive decisions that must be made where there is a consistent pattern to the solution, but you think that pattern could be improved? And are there any decisions where team members are relying on instinct to make a decision, even though a lot of data has been collected to support the decision process? You've already touched on both of those questions in your definition of machine learning. I'm wondering if there are other questions that you think are really good for business people to ask themselves when they're considering a machine learning problem.
Yes, my favorite question is, do you or your team has any task that is repetitive and you hate doing? It's basically something that you cannot automate easily because you would already do that. This is something that requires this level of decision making on the prediction or recognition, but something that is, let's say, below your pay grade.
Right.
We had one example of such project where a company was categorizing a lot of incoming emails into 3 categories. And then based on that category, they had to extract information from attached PDF and put them into Excel spreadsheet or the database. At their scale, that was like few hundred person hours per month. So it started to be significant cost and also taking people time to actually work on something that could provide more value. So we automated that process, categorized the emails and use the techniques to extract the information automatically so they don't have to touch the system. And funny enough, when we look at the accuracy or performance of that system, that was pretty low, like not extremely low, but given that this problem is not really too hard to solve of categorization of emails, like it could be compared to detecting spam, except it's more like not spam, but something useful, but similar techniques that can be used. So basically, we're looking at that the performance is not where it should be. So we look at the misclassified samples, so something that our system put in the wrong categories, and we discover that actually those are wrong labels. The people who categorized emails before made mistakes.
Uh-huh.
So that was interesting because then when we fix those labels, the system achieved better performance. But coming back to the question, what other questions are good is what can be automated, what risk you want to reduce, what you want to improve, like very high level. Mm-hmm. Before you even ask the question you mentioned, you can ask high level, like what is the biggest problem you're facing? Like what risk can be reduced? What do you want to improve? There's a probably 3rd category, but a bit more challenging to find. What new sources of information you are missing? For example, can we set up a camera setup that will analyze some events, detect some events, and then you will get the new data source from which you can make decisions. So machine learning and AI can be also used for automating, and that should improve your ability to make better, more informed decisions.
Very cool. And I like your framing of the question, what do you actually not like doing? Because I think you probably get more buy-in for your project when you're automating a process that people actually don't enjoy doing. And even thinking about how you're setting things up to gather the necessary data to get to the real problem can become like a sub-step of kind of the bigger piece of work that needs to be done.
Yeah, something that costs a lot of money right now to to collect the data, maybe that could be automated. But that data is also crucial to make good decisions.
Very interesting. We're going to definitely talk more about data, but before we get there, the other step I want to ask you about is the training of a model. And this is another part of machine learning that seems super mysterious for us non-technical people. How do you explain training a model to non-technical people?
Oh, you have to be very well educated. It's a trade secret. No, I'm just kidding. Trying to protect my job here. The training of a model does sound scary because people don't understand how it works. And especially from that perception that the models probably can do more, like more general intelligence. For this narrow intelligent model, you taking a lot of historical examples with labels and then using existing algorithms to find, you're just running those algorithms on that data, and they build a model. That process is called training the model. Now, it's not that easy because typically when you do that, the model sucks and it's not good enough for the business application. There's multiple steps that machine learning developer needs to take. Big problem in training of a model is that it's very easy to train a model that is very good on your training data set. So the data you use to build the model. And then when it's actually deployed in real life, it performs poorly. That's called overfitting. That's basically finding patterns inside that data set that are noise and just happen by chance. So a lot of the techniques, regularization, cross-validation are for preventing that to happen, making the model even less accurate on the training data set, but more generalized. Something that can be applied on the test data set as well. And a lot of effort goes into features engineering and selecting the proper features. When I'm talking about the features, the best analogy would be columns in the Excel spreadsheet, where each patient, for example, is a row, and then each column would be different characteristics of their blood, going back to our initial example. So a lot of that information, maybe you can pull additional information from other data sources. Let's say you also have information about the patient weight and height and other characteristics. Or maybe you can modify the existing data, like take weight and height and compute a BMI, because that's some indication about the patient's body mass index, right? So there is a lot of domain expertise that comes into play, and that's why machine learning developer typically shouldn't work alone, but be exposed to someone who knows the business and knows how the things work, what is important to look at. I heard the stories that machine learning developer build a model, presented to the business. We're like, yeah, everyone knows that. Like, that won't help us. Like, that is obvious. And we're like, oh, that wasn't obvious to me, but well, I proved it through the model. So a lot of that training, that probably goes more into setting the business use case. But there could be some caveats where there's features that are strongly correlated or some other things in the data set that are not obvious but may make the model better. So a lot of art to that process, using a lot of techniques and then dealing with something unexpected things like the missing data or some outliers. Or what do you do when your data is highly skewed because 99.9% of people are actually healthy? How do you make the model very sensitive to this 0.1%?
Yeah. So first off, I just want to say, I think your job is pretty safe because it seems like there is a lot involved in not just training a model, but training a model that doesn't suck and actually answers business questions. And also what seems obvious to one person might not be obvious to another. And so it goes back to that idea of having diverse skill sets on the team. And more importantly, really kind of understanding the data. And so I want to segue and talk a little bit more about data. This course really outlined a lot of the key elements that we should look for in our data when it comes to evaluating it for machine learning projects. So I learned about things like volume, dimensionality, breadth, diversity, and availability. And we hear a lot about big data. So the idea of having a lot of data, I wasn't too surprised to know that we need that for machine learning. And the idea of availability or access to the data, that also seemed pretty intuitive for me to consider when it comes to machine learning. But there were some other pieces or aspects of data that were quite new to me. Dimensionality, which is the number of unique attributes in a given record, breadth, which is the range of diversity in a data set, and perishability, this idea of how long your data will remain relevant or the rate of decay. Those were all really new things for me to think about. How do you advise organizations to get started in better understanding their data for a machine learning project and whether it meets these types of criteria?
So when we talk with different companies, initially it's just checking what kind of data do you have. Is it, for example, database, or is it handwritten notes? From those conversations, it seems there is some digital data or some data that could be easily digitalized. Learning more about what is actually covered. We have some data readiness document that actually asks those questions like, do you have a database, and what is being stored, how much data is there? But to be honest, until you see the data yourself, it's hard to say that yes, that's actually it. It could be that some financial institution is storing information about the clients and they want to predict the churn. So yes, it's database, you have information about the clients, you're looking into that, and then you realize they didn't store the transactions, they actually storing the current profile of the user. And you need the data from before user, for example, left or become delinquent, because you need to make prediction into future. So there's a lot of exploration to the data and validating a lot of assumptions. Because when you're looking at the data that you did not set up a structure of, you need to make some assumptions and then validate them with a customer. Is it really what I think it is, or is it something different? And what we provide to our customers are also recommendations how they can improve their data collection. It may happen that the data does not work for the problems they're trying to solve, but maybe there are different problems that could be solved with this data. And if they want to go to the original problem, this is how they should change their data collection practice. Or it could be there is not enough data right now and they have to come back when there is more samples, because when we tried the algorithms, the performance is below reasonable to invest into the solution.
And that's something I was going to ask you about, because what happens if you're getting in there and you're exploring and you've got the wrong data or you don't have enough data? Is it really just a matter of, well, we have to shelve that problem for now, or maybe we can answer a different question while you go out and get more data? What do you do in those scenarios?
So at our company, we try to identify more than one business use case, just in case the one that was initially brought to us does not work. And typically, there's more than one that customers are excited about. So it's not really a problem coming with one use case and only do this one. That's risky, but what do we do when there is not enough data? We asking ourselves, is there any other data set that we can use to solve that problem? Is there any public data that could be used to enrich the data that our customers have that will give us more signal that can be then used in the machine learning algorithm that make it more performant?
That's a great point, that it's not just only the data that is internal to that particular organization, but there's open data sets from government, there's data sets that you can purchase from data brokers and so forth that might be helpful in analyzing your problem. But also your point about don't put all the eggs in one basket. Let's try a bunch of different things here and let's see what other use cases we can work on. I think that's a really good thing for people to keep in mind as they're approaching machine learning projects. The course touched on making sure your data is in a usable format. You've mentioned that a couple of times. Can you talk about structured versus unstructured data and also how we prepare data to be used in machine learning projects?
Yeah, so structured data is mostly SQL databases or Excel spreadsheets, something where you have a table with rows and columns. That's the perfect data for machine learning. But a lot of the information that we store is in the form of images or the free text. And that is not as easy to process with machine learning. Some newer algorithms actually are pretty good at processing this type of unstructured data. But for a lot of application, what you have to do is, especially with text, use some techniques to convert it into table with multiple features, multiple columns, and put some numbers in there. There are whole fields of actually making this transition from unstructured to structured data. But typically, the newer algorithms are actually not bad, especially in the field of computer vision and the advancement that was made in around 2012 with convolutional neural networks enabled us to process it easily and achieve pretty amazing results.
Yeah, that was something that was covered in the course too, about why is this taking off right now? And it really talked about the GPUs and 2012 being a bit of a pivotal year in being able to have the speed to run a lot of these algorithms and process the masses of data. So it's interesting to consider, why is this happening now and where it's going to be in the future as we continue down the path of Moore's Law and doubling processing speed every 18 months or so.
Yeah, there are a few factors for why it's happening now. Because AI, it's not a new field. It existed since the birth of computers, pretty much, from the early 60s or late 50s. But there was not enough computing power. People were very excited. There was undergrad summer internship position at MIT that asks for intern to write a machine learning program that will describe what is visible in the image. We solved that around 2010, 2012. So expectation was that was undergrad project for summer intern back then, which of course did not work. Few issues, algorithms, they do evolve and there are of course newer techniques, but a lot of them is reusing the techniques from the 70s or 80s and adding some more complexity to that. And that complexity is enabled by the fact what you told, like existence of GPUs or how much computing power we can use right now. And the second very important factor is amount of data. Internet, ability to handle big data, that definitely enables us to build better algorithms because you either have a very good signal in your data. If you don't have a good signal, then the more data you have, the higher chances you will find it. So for image recognition, the models are trained on millions of images that are categorized and labeled.
Yeah.
So it took a lot of effort to build that data set.
It's amazing to try and even get your head around that. And one thing I really liked in the course is it does go into that history. And there's a whole chapter about the history of AI that if anyone's interested in kind of the trajectory of how we got here, I think people will find that really fascinating. I'm also really curious about the people side of the business. And in particular, I'm wondering what it's like for you being a data scientist. And really, what does data science mean to you?
So that's a good question. I actually don't like the term data scientist because it doesn't tell you what you're doing. For me, data science is more like a team sport where there are different roles that all act together to make sure that you can find some value from the data or you can find some application for the data and make sure it can be deployed or integrated with a business. And there are multiple roles like machine learning developer, there's a software developer, data analyst, business analyst. So it takes a village to train a model, to build a data science product.
Yeah, no, that's actually a good point that you think maybe the term itself might be a bit of a misnomer. It doesn't quite describe accurately what is actually involved.
Yes, it came from the early days, from 2008 and the first data science team at LinkedIn. Basically, back then, data scientists had to have all those skills because otherwise it would be very hard to convince a business to build the whole team of different roles. So the initial data scientists were multidisciplinary. They could create the software to use the model. So a lot of that perception came from early days when data scientists were described as unicorns that can code, understand math, and have domain expertise. But it was quickly validated that it's not easy to find those people. And even if you find them, they're generalists. They could be expert in one domain, but in other domains, they most likely will be generalists. So the concept shifted from one person who can do everything to a team that has enough capabilities to build a good data science product.
I'm imagining a team of really great horses, but not the unicorn that is elusive that we'll never find.
Maybe something like that.
All right. Well, I want to segue and talk a bit about communication because that was one of the final modules in the course. And of course, that's totally in my wheelhouse. That's what I study, communication and technology. And one of the areas that needs to be communicated to customers is how machine learning projects differ from a traditional project. And you had some really interesting thoughts to share about educating customers in this module. What should people expect in a machine learning project when it comes to timelines and when it comes to results?
Timelines and results. So how we structure our initial investigation into business use cases is that we time box it. Machine learning is very unpredictable. It's pretty much exploratory research. When you're building the model, you don't really know what will be the outcome. You know that the model will be predicting this, but you don't know how accurate. And maybe after first iteration, you already have a good enough model and you can stop. But maybe it's not good enough, and then you have to find new data sources and you have to find new features, do more features engineering, different algorithms. So it's very hard to actually tell upfront how long it will take. That's why we time box it, and that's why we choosing multiple use cases, not to get stuck on one and then fail the project and don't provide any value to our partners. With multiple use cases, it's very unlikely that all of them will fail. So far, actually, not a lot of them did. It's also because currently there's nothing being used. So it's hard to find what is the threshold. So we're focusing mostly on translating the model performance to dollar values, trying to educate customers on what the model is actually doing, how it can be used in the model. And given these assumptions, this is how much plus minus will save you or generate extra revenue. So we are approaching it more from the perspective of speaking the language of our partners and not really, the model has 85% accuracy with 90% recall and 70% precision. Oh, that's very interesting. What does it mean? So we're trying to transfer it to how it will impact their business. What does it mean for their business?
Yeah, there were a lot of examples in the course about how to tell a good story about a machine learning project in real language. And I also appreciate what you're saying about spreading the risk of the project out by trying many experiments, because I think that's something that can be hard for organizations if they undertake a research and development experiment and they don't get any results. It can feel incredibly disappointing, but by running a lot of small experiments, you're very likely to improve the odds, I would assume, of getting something that's really useful for your business. So
yes, there are diminishing returns, right? You doing 20% of effort to reach 80% of results. It's true for a lot of those problems. It's almost bad to optimize one model to make it better if there are other problems that could be solved and you can get to some results faster.
Just before we wrap up here, Marcin, I want to ask you, is there anything else that you wanted to share about machine learning, data science, artificial intelligence in general?
Yes, I think this is a field that will change our lives. I think that's the next industrial revolution. And I want to say to people not to be scared about it and also to be scared about it. What I mean by that, it's not really scary right now. It's not killer robots or anything like that. But if we think about it, that it will make a lot of decisions, we have to make sure that it's not biased, it's ethical, and we understand to some degree why those decisions are being made. Like when I ask you, how do you recognize my face? You're like, well, I know it's your face, right? So the concept of machine learning being a black box, it's so similar to the black box that we have in our head, but people don't even realize it. And they're scared of like, oh, I don't understand how this model works, so how can I trust it? Do you understand how your head works? Not always. But for some decisions, you know how you reason about them. You know that, if that happens, then that happens. So there's a lot of research in machine learning to shed some light on this black box and to explain to some degree why the decision has been made in a way it has been. But also another problem is the decisions or the predictions made by machine learning models will depend strongly on the data that is used. And a lot of times this data is heavily biased. It's especially explicit or visible in the banking data, the racial discriminations and things like that. If the data has it, even unintentionally, it may impact how the decision and not helping to fight it. So it's very important to make sure that the AI that we build is ethical and we try to avoid biases. Sometimes you will miss them, but you really, really have to try to avoid it and make sure there's some governance and oversight of what data is being used. Is it fair? And are those models, at least to some level, when you use some explanation, that those predictions make sense?
Thank you for saying that. And that, really speaks to the heart of the research that I'm about to embark on around artificial intelligence and ethics. And it's so nice to know that there are very responsible and ethical people like yourself who are taking the lead on this and really thinking about these issues as you go about your work. Marcin, I just want to say thank you so much for being here today on the podcast and for sharing your knowledge and helping to unpack machine learning and make it a little more accessible for everyone. Thank you so much.
Oh, it was a pleasure. Thank you for having me.
That's our show today. I hope you enjoyed it. If you like the show, please give us a rating. It helps other people connect with us. You can reach me at backtoschoolagain.ca or at schoolagainpod on all the usual social channels. I'd love to hear your story. Back to School Again was recorded at Unit B Co-working, located on Treaty 6 territory, the traditional homeland of First Nations and Métis people. A huge thanks to our series partner, Athabasca University, for supporting the show. You can learn more about Athabasca University and their PowerEd offering at powered.athabascau.ca and use the offer code Ingram20 to get 20% off your course. Back to School Again is proud to be affiliated with the Alberta Podcast Network. Find out more at albertapodcastnetwork.com. See you next time.